Okay, so here we are looking at joint D. I've already drawn in my 4 kip force acting downward. Okay, I went ahead and found the angle, except I have to type the wrong letter here. Okay, and let me tell you how I got that. The opposite over the adjacent. If this is the angle D right here, okay, then I know that this, I'm going to use this to be my imaginary right triangle. Okay. The opposite is 6 feet. The adjacent is going to be the 7 feet. Okay. We knew that this distance was 4 feet at the last joint. Okay. Which means this distance is 3 feet. So our adjacent is 3. We get the arctan of 2, and that's 63.4 degrees. Okay. Now, here's the other thing. Now we know this member, okay, and we know this member, so we have to draw them the way they are, okay? So we have already found at joint A that AD was in tension, okay? So that means we have to draw it in tension again, all right? So when we draw it in tension, the arrow points away from the joint, okay? And then we also found that CD was also in tension. Okay? So we have to draw it in the same way. Alright, now let's label those. Well, let's go ahead first before I switch over to labeling and look at BD. Okay? I have a negative 4 kips in the Y direction, and BD is the only thing that's going to counteract that. Alright? So it has to have a positive Y component. So I have to draw it going up, okay, and away from the joint. So it's also in tension. Okay? So we'll label those for you. FBD. This is FCD, which is equal to 0.445 kips, and this one was FAD, which was also going to be 2.44 kips. Right? Okay, so we know this angle, we know all these forces. We can write sum of forces X or sum of forces Y to solve for FBD. Okay, so if we do the sum of the forces Y is equal to 0 is equal to FBD times the sine of 63.4 minus 4 kips. Okay, when we solve that for FBD, we get FBD is equal to 4 kips divided by the sine of 63.4. And FBD works out to be 4.47 kips. Alright, now it's came out positive, so that means it's going the way we drew it, and we drew it going away from the joint, which we say is in tension, so we put a T after that. Alright, now let's say I just want to double check. Alright, I can now plug into sum of forces Y at this point, at sum of forces X, since I haven't done it, and see if everything works out correctly. Okay, so if I have 0.445 from FCD, okay, plus 4.47 times cosine of 63.4 degrees minus FAD, 2.44. Okay, let's see what I get. I get 0 is equal to 4.4. That's not bad. I end up with 0 is equal to 0.006 kips when I plug all those numbers in, and that's pretty good. So that's just due to rounding errors. Okay? So now we're done with that problem, and we know the force in every member.